Okay, this is lesson 5-8, scale drawings and models. You can write that at the top of your notes. So the first thing we're going to look at, example 1, we're talking about what's called scale or a scale factor, scale model, but your scale. So this says, suppose a model of a dragonfly has a wing length of 4 centimeters. So what that means is a model, like what we've just done in class, like your toy version of yourselves, that is a model. It means not the real thing. Could be smaller or bigger, we don't know. But it has a wing length of 4 centimeters, so more like a picture or a map. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? So what they're saying is, if the model is 4 centimeters, but the real thing is 6 centimeters, what calculation or measurements are they using to get that? So what I want you to write down is, I want you to write down the word model over actual. Write that down. That is how we always set up our scale. It's the model number over the actual number. So they put 4 over 6, and what you do, you're setting up a proportion, just like what we did when we were solving for our toy measurements. So we set up the one they gave us, 4 centimeters on the model, and it was really 6 centimeters in real life. Then for our scale, we will put 1 for the model length, and we want to know, okay, how long does that represent in real life? So here is our proportion. From here, we are cross multiplying. We have 4 times x, which is 4x, and 6 times 1, which is 6. So we get this, 4x equals 6. To solve for x, you have to divide both sides by 4. When we do that, this cancels, and we're left with x equals 6 divided by 4 is 1.5. So my scale is that 1 centimeter equals 1.5 centimeters, or you could write it 1 centimeter over 1.5 centimeters. We could write it like that, sorry. Okay, so what I want you to do is you're going to try 1B. You're just determining the scale. Okay, I don't want you to do 1A, just 1B. Work that out, pause the video, and then I will go over it with you. So on 1B, it says the length of the model of a bridge is 16 inches. The actual length of the bridge is 50 yards. What is the scale of the model? So we have that on the model, 16 inches. The actual length is 50 yards. So remember, it is always model over actual. Okay, so I have inches over yards, which means my other fraction still has to be inches over yards. And it says, what is the scale of the model? So we're trying to find 1 inch, or 1 inch is how many yards? I'm recording. Okay, so 1 over what we're looking for. Sorry, y'all. Okay, so we cross multiply. 50 times 1 is 50 equals 16x. We divide both sides by 16. Sorry, I typed it wrong. Okay, so we get 3.125. So that just means our scale is 1 inch on the map would be 3.125 yards in real life. That would be your scale. Your scale has to go back and have both of them and your units for this. Okay, before we look at example 2, I want to talk about this up at the top, scale factor. That's different from your scale. Okay, so this says if the scale drawing of a model have the same unit of measure, the scale can be written without the units. That is called a scale factor. So a scale factor is when your scale has the same units. Like before, we may have had centimeters to inches, or in this case, inches to feet. If they're in the same thing, like both inches or both feet, that is called a scale factor. So this says, for example, use that 1 inch equals 2 feet. So that means 1 inch on your model would equal 2 feet in real life. Well, if we wanted to turn that into a scale factor, we would make them both the same. You typically always, when you're making them the same, change it to the smaller one. That's the easiest way. We know inches are smaller than feet, and then we also know that there's 12 inches in 1 foot. So if we have 2 feet here, that would be 2 12 inches, which is 24 inches. So 1 inch over 24 inches, that is now a scale factor where we could just say it represents an actual distance of 24 units, or it is 1/24 the size of the actual object. You no longer have to say inches if they're both in the same thing. Okay, we're not always going to be dealing with scale factor. Now let's look at example 2. So it says the blueprint of a skateboard ramp shows that its length is 11.4 inches. So that's a blueprint, which means it's a map. It's not real life. 11.4 inches is on the model. If the scale on the blueprint is that 1 inch equals 6 feet, what's the length of the actual skateboard ramp? So we would set up a proportion. Our scale is your first fraction. Model over actual, so 1 inch over 6 feet. And then they gave me 11.4 inches. So I have inches over feet, so my other side will still be inches over feet. So since they gave me 11.4, that was the model number, so that goes on top. So what we're trying to figure out is the bottom number, the actual length of the skateboard ramp. So from here is where you would cross multiply. So we have 1 times x, which is x, and then 6 times 11.4, which comes out to 68.4. From there, there's nothing to divide. So that's it, we're done. The actual length of the ramp is 68.4 feet. Okay, make sure you put those units. Now right here, they look at scale factor just to show you that if you changed feet to inches, okay, if we were to do that, let me scroll down, we would get that it is 820.8 inches long, the actual ramp, or we just got that it was 68.4 feet. Okay, so what I want you to do is try number 2 down here. Okay, a map of a natural history museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale on the map is 1 inch equals 8 feet, what is the width of the actual exhibit room? So set up your proportions and solve that. Pause the video to do so, and then I'll go over it with you. Okay, number 2 says the map of a natural history museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale of the map is 1 inch equals 8 feet, what is the width of the actual exhibit room? So they gave us our scale. Our scale was, I lost my place, 1 inch equals 8 feet. So 1 inch over 8 feet. Almost wrote feet first. So then it says on the map, it shows the dinosaur exhibit room to be 7.25 inches wide. What is the actual width? So they gave me inches. If you notice, we have inches over feet, so it has to stay inches over feet. They gave us inches. They gave us the model of 7.25, and they said, what is the actual width? So here's our proportion. So we cross multiply. I have 1x equals 8 times 7.25 is exactly 58. And this one you don't even have to go further because it just came out to 1x. So the actual width of the room is 58 feet. If they had wanted us to find the scale factor, we would come back up here. We have inches and feet. There's 12 inches in a foot. So we would say 58 times 12 to change this to inches, basically, to know that it is 696 inches wide or 58 feet wide. Okay, example 3. Now we're going to look at scale drawings. So it says Lila is painting a mural at the community center on a wall that measures 18 feet long and 12 feet tall. So she's painting a picture on the wall that are these measurements. It says make a scale drawing of the mural. Use a scale of 1/4 inch equals 3 feet. And the reason they chose a fraction is because they said use 1/4 inch grid paper. So we're not really going to worry about drawing these so much today as we are just looking at it. All that means is if you're using 1/4 inch grid paper, graph paper, the squares are already 1/4 inch long. So what it's saying is basically each square would be 3 feet in real life. That's what that scale means. 1/4 inch equals 3 feet. But we are going to at least calculate what the measurements would be if we were going to graph it. So 1/4 over 3 feet, because that is our scale. It's the model over the actual length, equals, well, we know in real life it's 18 feet long. So let's figure out how many inches long that would be on our model if we had to draw it. So they said L for long. We could use X. It doesn't matter. But you're cross multiplying. You're setting up a proportion. If you need to change 1/4 to a decimal, you can. It just means 1 divided by 4, which is 0.25. So we have 0.25 times 18, which is 4.5, and 3 times L. From here, we still have to solve for L, the new length. So we divide both sides by 3. It cancels here. 4.5 divided by 3 is 1.5. So the scale drawing of that mural is only going to be 1.5 inches long. Okay, or 1 1/2 inches, which would be 1, 2, 3, 4, 5, 6 squares if you were to count the 1/4 inch squares. Anyways, we're not so worried about that. But now let's look at the width. So it told me, how tall it was, So the width, but it says W. So we still have our same scale. That has not changed, okay? Your scale doesn't change when you're still on the same problem. 1/4 over 3. But now we're looking at the width, and the actual length was 12 feet tall, so over 12. So again, you're cross multiplying. 3 times W is W. 1/4 times 12 is 3. Divide both sides by 3, and you get that the width equals 1. So our measurements on this little one, even though it was really 18 feet by 12 feet, they went ahead and showed you what it would actually look like. It would be 1.5 inches long and 1 inch tall. Okay, so then now you're going to try a problem. You don't have to actually graph anything. You're just going to find what your measurements would be. So number 3 says an architect is designing a school courtyard that's 45 feet long and 30 feet wide. Make a scale drawing of the courtyard. Use a scale of 0.5 inches equals 10 feet. Pause the video, try that problem, and then I'll go over it with you. Okay, last problem says an architect is designing a school courtyard that is 45 feet long and 30 feet wide. Make a scale drawing of the courtyard. Use a scale of 0.5 inches equals 10 feet. Okay, so first of all, a courtyard just means like an outside play area. It's always in the shape of a rectangle. So it told us that it's 45 feet long and 30 feet wide. It tells us to make a scale drawing, and you can draw it, but it's more on getting your calculations on knowing what to draw. So we're going to figure out how long these sides would be on the scale model. Okay, they told me the scale is 0.5 inches equals 10 feet. So I know I have 0.5 inches over 10 feet as my first fraction. That's my scale. It's always a model over actual. So then on this side, I also have model over actual. We don't know the model length on this one. They gave me the actual lengths. So I'm going to figure out this side first. So I don't know this number yet. I have to figure it out. So we cross multiply. Have 10x equals, I have 0.5 times 45, which is 22.5. And then I divide both sides by 10 to get 2.25 inches. So it's going to be 2.25 inches long. And then I set up the same thing. My drawing did not change as far as your scale will be the same. It's just now we're finding a different measurement. We want to know how wide is it going to be if the actual one is 30 feet wide. So again, we're cross multiplying. So I have 10x equals 15. You can double check. 30 times 0.5 is 15. Divide both sides by 10. And we get 1.5. So that means it is 1.5 inches wide. So we would be able to draw that courtyard, or the scale model of our courtyard, because it would only be 1.5 inches wide, 2.25 inches long, to represent that courtyard using the scale of 0.5 inches equals 10 feet.